So this is the lesson for 9-3. What we're talking about today are residual plots. Remember what a residual plot is that we have a scatter plot of your data. We calculate it. We calculate the line of best fit that goes through it. The scatter plot is your actual data. Your line of best fit that we get through doing the linear regression is your predicted data. Then we take this blue line and we turn it on its side so that it looks like this. If the dots are randomly all over the place, that indicates linear, all right? If the dots are randomly all over the place. So like this one where there's no pattern to the data, that represents a linear relationship. When it is flatlined like these two, that represents linear as well. It's going to be non-linear when it does something weird like this, where it curves up and curves down at the same point. That's going to be non-linear. It's also non-linear when it is a U-shaped residual plot, all right? So most of the time on the Regents exam, if they have this question, it's most of the time a multiple choice. They'll either give you, most of the time they'll either give you this picture or this picture, asking you whether it's linear, which one of the following graphs indicates a linear relationship, or which one of the following graphs indicates a non-linear relationship. So you really need to know that the scattered all over the place dots are linear, the U-shaped is non-linear. Those are probably the two biggest ones that you need to know. So today what we're going to do is we are going to calculate and draw our residual plots by hand, all right? So what we're going to do is we're going to calculate the linear regression equation for the data first. Notice that these directions say that we're going to round to the nearest tenth. So on your calculator, the first thing that we want to do, all right, hold on, I need to. So the first thing that I would suggest doing is clearing your memory. Second plus 712, second plus 712 to clear your memory, all right? Remember that you have to have, for your R value, you have to have on your stat diagnostics. Remember, to do your stat diagnostics, you hit the mode button and then go all the way down. It's always a good thing to make sure that your stat diagnostics are turned on. We're not going to be using the R value today, but it's a good thing to have turned on anyway. So we want to type in our data into the L1 and L2. So we need to hit the stat button and then edit. This is going to be your L1 column. This is going to be your L2 column. So go ahead and type in that data so that we have 30, 40, 50, 60, 70, 80. And then in our L2 column, we have observed breaking distance. Always double check your data to make sure that it is correct. Now, the way that you are going to find your predicted data. Now, this is the same way that you're going to find it on your homework. You have like 5 or 6 questions that are just like this. To find your predicted breaking distance, we need to do the linear regression. So we need to go to Stat, Calc, number 4, which is linear regression. Stat, Calc, number 4. It asks you, do we want to use L1 and L2? Yes, we do. So we just want to go down to calculate and hit enter. We're going to, the directions here said to round it to the nearest tenth. So our linear regression equation is going to be y equals, notice that it's ax plus b, so it's going to be 5.4 x. Now be careful, our b value is negative. So that negative is going to be a minus 133.9. So this is our linear regression equation. Now to get our predicted value for these, the easiest way, now you could take and you could sub in 30, 40, 50, 60, 70, 80 in for our X right here. We could do that if you wanted to, and you could do it out by hand, but the calculator will do it for you, all right? Might as well take advantage of the calculator. So we're going to go to Y equals, and we're going to type in our equation. So 5.4x, make sure that you use the X next to the alpha button. All right, make sure that you use the X right there, not the time sign. Minus 133.9. And now to get our predicted values, we're going to use the table function. So second and table, which is your graph button. Now, notice that our X values are 30, 40, 50, 60, 70, 80. If you really, really wanted to, you could just scroll down. It would take a while to get to 80, all right? So there is an easier way that you can change what the table counts by. So I'm going to show you that today. So hit second. Notice above the window button, at the top, it says TBL, that's table, set. So we want to do second and then that window button. So this is for the table setup. It asks, what do we want our table number to start at? Now, normally the default on here is to have your table start at 0, because normally it shows 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's starting at 0. This triangle or delta, and then the table says that it's counting by ones. That's why your default table counts by ones and starts at 0. Notice our table is at 30 and goes to 80. So we could start our table at 30. And notice that we are counting by tens. So we could change our little triangle table there to count by tens. Now, there's no enter button or anything like that, all right? So we could just go back to the table now by hitting second and graph, which is table. And notice that our table counts by tens now, all right? Notice that our table counts by tens. So our predicted value for 30 is 28.1. Our predicted value is 82.1 for 40. 136.1. And again, you could have found these all by hand by subbing them in. I personally like using technology, so I would use the table button. So that's how we get our predicted values. Now, to get your residual values, notice that it says the residual value is the observed value. So the data from your scatter plot, it's the actual value minus the predicted value. So what you're actually going to take is you are going to go ahead and take these numbers from your L2, and you are going to subtract. All right, you're going to subtract your predicted values. And it's going to equal your residual values. So you're taking this column in the green, subtracting the column in the red to get you your residual values. So this minus this, all right? So 48 minus 28.1 gives you 19.9. 80 minus 82.1 gives you negative 2.1. It's okay to get negatives. 120 minus 136.1 gives you negative 16.1. 180 minus 190.1 is negative 10.1. 240 minus 244.1 gives you negative 4.1. 320 minus 298.1 gives you 21.9. So again, you have to remember that your residual value is your actual value, your actual data from your data table, minus your predicted value that we got from the linear regression equation, and that equals your residual value. Now we're going to plot the data. All right, let's plot the data. So when we go to plot the data, what you're actually graphing here, your X value is your L1 column. All right, your X value is your L1 column, and your Y value is your residual value. So we're graphing this first column with the second column as points. So your points are your L1, comma, your residual value. So the L1 is how many we go over. Your residual value is how many we go up or down. So our first point is 30, 19.9. So over to 30, up to 19.9. And all we're going to do is we're just going to make a dot right there. 40 and negative 2.1. So over to 40, down to negative 2.1. And you just have to estimate. 50 and negative 16.1. 60 and negative 10.1. 70 and negative 4.1. And 80 and 21.9. So there's our residual plot. So when you take a look at this, you're then going to have to answer, is it linear or nonlinear? So notice what our values are doing here. Notice that it sort of looks like it's a U shape. If it's a U shape, is it linear or nonlinear? What is it? Nonlinear. All right. So this one would be nonlinear. And that's the process that you're going to have to do. If we did take a look on this one, if we did take a look at our R value, our correlation coefficient, our correlation coefficient for this one, our R value was 0.98. 0.98 actually indicates that it's more linear, but remember your residual plot of your data is sort of the trump card. It supersedes everything else, all your other data. So this is non-linear. Let's take a look at one more. All right, on this one, we have the number of absences and your grade. All right, the number of absences and your grade. So this is going to be your L1. This is going to be your L2. So let's go ahead and type those in. Remember, you can clear your L1 and L2 if you go up, all right? If you go up to where the titles are, hit clear, and then the down arrow, it clears out that whole column. So go up to the title, hit clear, and then hit the down arrow. It clears your whole column. So let's go ahead and type in that data. Always, always, always double check your data just to make sure that you typed it in correctly, because if you have even one number wrong, it's going to throw things off. So always double check your data. Notice the directions for this question say round to the nearest whole number. So now that I got my L1 and my L2, I want to go to Stat, calc number 4, which is linear regression. I do want to use my L1 and my L2. So my linear regression equation is y equals, I have a -3 there, x plus 93 when I round to the nearest whole number. Notice that my R value of -0.94, now that's indicating that it's going to be linear. But remember that our residual plot supersedes any R value. So for the predicted values, I want to go to my y equals. I want to clear out the equation from the previous problem, and I want to type in -3x plus 93. And now I want to go to find my predicted values from my table. Now, your table, because we messed with the settings in the last problem, we got to change them back, right? Because notice that now for our x values, we have 0 through 10. So I want to go back to my table setting, second and window, and I'm going to change it back to what it started off at. I want to start at 0, and I want to count by ones. All right, start at 0, count by ones. You could have also went through and just erased the memory and started over again. That's fine to do it that way. Second and table. So now you have to be careful because these are not in order. All right, these are not in order. So 0 is 93. 5 is 78. 3 is 84. 1 is 90. 2 is 87. 3 is 84. 10 is 63. 0 is 93. 6 is 75. 1 is 90. Wait, did I mess that up? 0 is 93, not 90. To get your residual, all right, to get your residual, we have to do this one minus this one. So you're doing that column minus that column equals that column. So 95 minus 3 is 2. 73 minus 78 is -5. 84 minus 84 is 0. 92 minus 90 is 2. 92 minus 87 is 5. 80 minus 84 is -4. 65 minus 63 is 2. 90 minus 93 is -3. 70 minus 75 is -5. And 88 minus 90 is -2. So now when you go to graph it, you're using these two columns, all right? Because this L1, that L1 are your X values, all right? Those are found along this line. So 0, 2. So over to 0, up to 2, we're putting a dot. 5 and -5. And again, these aren't going to be in order because our X values aren't in order. 3 and 0. 1 and 2. 2 and 5. 3 and -4. 10 and 2. 0 and -3. 6 and -5. And 1 and -2. So when we take a look at these dots are really all over the place, all right? Some are above, some are below. It doesn't seem to be doing that where one goes up and one goes down thing. they're really just scattered all over the place. So since there is no pattern to the data, this has to be linear. Since there's no pattern to the data, this has to be linear. Questions on any of these? All right, taking a look at the next slide really quick. All right, on your homework, you had a question that looked like this, where you had to say whether it was linear or nonlinear. This represents scattered data all over the place. So this would be linear. You're gonna have questions just like this. And then in this type of question, this is the type of question that you had the other day. Looking at the residual plot, all right, the R value looks like it's linear. The actual data of the scatter plot looks like it's linear. You have some up above, some up below, some down below. So that's no pattern. So this would definitely be an example of linear.